Lesson 5-2 Prime Factorization, and in this lesson you learn to find the prime factorization of a composite number. When are you ever going to use this? Knowing how to find prime factorization of a number can help you determine the possible dimensions of a box when given the box's volume. And the terms we will use for this lesson: composite number, prime factorization, and the factor tree. Okay, let's take a look at this example. Each rectangle shown below has an area of 12 square units. The dimensions of the rectangles are 1 by 12, right here. Oops, right here. Okay, that's 1 by 12, 1 by 12. And you also have 2 by 6 right here. 2 by 12, 2 units by 6 units. And 3 by 4, 3 units by 4 units. Okay, so the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, so these are all factors of 12. Okay, since 12 has 6 factors, it is considered to be a composite number. Definition of a composite number is any whole number greater than 1 with more than 2 factors. Again, any whole number greater than 1 with more than 2 factors. Okay, so write the oops, not that one. Write the definition down. Okay, in your notebook, because this becomes going to be very important of a composite number. So after that, the previous lesson that we just had, when you create a rectangle such as this one, and you have more than one rectangle, it is considered to be a composite number. Okay, but if you have a number that you can only make one rectangle with, such as 2, 3, 5, and 7, and 11, okay, with square tiles, it is considered to be, they are numbers that are considered to be prime numbers. So if you notice, the number 12 has 3 rectangles. You can make 3 rectangles out of the number 12. It is a composite number. But if you have a number that you can only make one rectangle with, such as 2, 3, 5, 7, and 11, okay, they are considered to be prime numbers. Definition of a prime number, again, write this down. A prime number has exactly 2 factors, 1 and itself. Okay, the one that's missing is that a prime number is a number greater than 1 also, and has exactly 2 factors, 1 in itself. And you might ask why 1 is not a prime number, because the definition says exactly 2 factors, and 1 has only 1 factor. Okay, which brings us to the next paragraph. Next paragraph simply states that 0 and 1 are neither prime nor composite. 0 has an endless number of factors, or infinite number of factors. The number 1 has only 1 factor itself, and that's the reason why 0 and 1 are neither prime nor composite. Let's take a look at example number 1. Determine whether 18 is a prime number. Draw rectangles to explain your answer. Okay, so let's draw a rectangle for 18. This is one kind of rectangle, 1 by 18 rectangle. I can also draw a 2 by 9 rectangle, and I can also draw a 6 or 3 by 6 rectangle. Okay, since you can draw more than one rectangle for number 18, okay, the factors of 18 are 1, 2, 3, 6, 9, and 18. And since 18 has more than 2 factors, it is considered to be a composite number. Okay? And that's when you're using rectangles. Let's take a look at the next one. Every composite number can be expressed as a product of prime numbers. This is called the prime factorization of a number. To find the prime factorization of a number, you can use a factor tree for division. Remember what a factor is. A factor is the number that you use to get a product. So a factor times a factor gives you a product. So a factor times a factor equals your product. So in multiplication, you call those two numbers factors. Okay? So going back here, to find the prime factorization of a number, you can use a factor tree. uh, or division, like in this one in example number 2, find the prime factorization of 36. Let me put up the screen shade. So where is my screen shade? There it is. Bring it down a little bit. There you go. Find the prime factorization of 33. Method 1, let's use a factor tree. Okay, so 36 starts with 36. Factor 36. Okay, find any two factors of 36. Since 36 is divisible by 2 according to our divisibility rules, we can use that. 2 times 18 is 36. Okay, because 36 divided by 2 is 18. Circle the prime number 2. So after you get the prime number, stop factoring at the circle. 18 is not a prime number, so we continue factoring. Find two factors of 18. Okay, we can see that 2 times 9 is 18. Again, 2 is a prime number, 9 is not. Now again, let's answer this question. How do you know that 2 is prime? Because 2 has only two factors, 1 and itself, which is 2. Okay, and at the same time, 2 is the only even number that is prime. So 2 is the only even number, okay, that is prime. All other prime numbers are odd. Okay, so let's get two factors of 18. We know it's even, so it's not prime. Okay, 2 times 9, circle 2 again because that's 9. Okay, we know that 9 is not prime because other factors of 9 are 3 and 3. Well, 1, 3, and 9 are factors of 9. So we use 3 and 3 as two more factors of 9. We continue our factor tree. Okay, circle prime numbers 3 and 3. Once everything has been circled in your factor tree, you're done with your prime factorization. So you can see here, okay, the prime factorization of 36 is equal to 2 times 2 times 3 times 3. Okay, why is it called prime factorization? Because all these numbers are prime and they are all factors of 36. I'm sorry. Moving on. And let's use method 2, using division. And this is actually, I can take out my shade now. We can start with this one. So using method 2 for division, okay, begin with the least prime that is a factor, then divide the quotient by the least possible prime factor. In this case, it is 2. Repeat until the quotient is prime. What does that mean? So basically, this is what I call the step down method or the drop down method. You get the number 36, okay, and then basically what you do is draw a line on L, so sort of an L, put 36 in there, and find the least prime factor of 36. Since 36 is even, we know that the least prime factor of 36 would be the number 2. And we divide 36 divided by 2 will give you 18. We know that 18 is not prime because it is even, so we continue our drop down. Okay, we drop down. Find the least prime number that can go into 18, and that is again 2 because that's an even number. 18 divided by 2 is 9. 9 is not prime, as we know, because the factors of 9 are 1, 3, and 9. So the least prime factor that can go into 9 is 3. 9 divided by 3 will give you 3. Everything's prime. We stop factoring. Okay, so this is the drop down method. Okay. And that's an easier way, or it's up to you. It's another way of finding the prime factors of a number, in this case the number 36. Let's take a look at example number 3. Geometry. The volume of a box is found by multiplying its height, length, and width. If the measure of the volume of the box is 255, what could its dimensions be? Pay attention to this example because this example will have a similar question on the test. So let's first let's look at the question. If the measure of the volume of the box is 255, what could its dimensions be? Okay, we need to find the prime factorization of 255, and what you don't know is that to be able to find volume, you need to multiply length times width times height. These are the dimensions that we are looking for: length, width, and height. So that means we need to find three numbers. When you multiply together, will give you 255. And that's exactly why we're doing our prime factorization. Okay, so we want to find the prime factorization of 255. And we know that it ends in 5. Therefore, according to our divisibility rules, it is divisible by 5. But if we add 2 plus 5 plus 5, it's 12. Okay, it's also divisible by 3. So you can either divide this by 5 or divide this by 3. It doesn't really matter. Let's do 3. 255 divided by 3 will give you 85. So the two factors of 255 are 3 and 85. We know that 3 is prime. We circle that. We stop our prime factorization from there. And we know that 85 is not prime because it ends in 5. And according to our divisibility rules, it is divisible by 5. And if it's divisible by any other number than 85 or 1, it has more than 2 factors. Therefore, it's a composite number. So we continue factoring. Two factors of 85 are 5 and 17. 5 is prime, 17 is also prime because both of them have only 2 factors. Therefore, the dimensions of the box are 3 by 17 by 5. The length is 17, the width is 3, and the height is 5. So you can interchange the numbers for length, width, and height. It doesn't really matter. So the prime factorization of 255 is 3 times 5 times 17. So 3, 5, and 17 are factors of 55. Thus, the dimensions of the box could be 3 by 5 by 17. Okay? And that's the end of this lesson. Thank you for watching.